Can somebody tell me if you can hear me?
Sir, wait, sir. Yes, sir.
Yeah, you
Sir,
can.
hearing, sir.
Yeah, great. Thanks.
Shivaraj. Shivaraj. Professor Satyam, sir. நான் ரெடி. நான் சாப்பிட்டு அப்படிங்களா? சரி.
Gandhi, shall we start?
சொல்லுங்க சார். ஸ்டார்ட் பண்ணிடுங்க சார். ஓகே சார். தேங்க்யூ சார். Good evening to all. Behalf of Organized Secretary, Department of Statistics, Bharathiar University, Coimbatore, International Webinar on Data Science using Python. The honor of living legend Professor C.R. Rao century birthday celebration associates with C.R. Rao birthday celebrations. This session is second session. Today is second session. Morning is 2 session is completed and evening session is started. Right now call upon Professor K.M. Shaktivel sir. Introduce the
Hello.
Okay, thank you.
Good evening to all participants. It's a great pleasure to introduce the day one of International Webinar on Data Science using Python, session 3, resource person. Dr. Pavan Lingaras is a graduate of IIT Bombay with graduate studies from University of Regina, Canada. He is currently a professor and director of computing and data analytics at St. Mary's University, Halifax, Canada. He is also internationally active, having served as a visiting professor at Munich University of Applied Sciences, Germany, IIT Gandhinagar, as a research supervisor at Institute of Superior D. Castino D. Dennis, as a scholar in residence, and as a Sastri Indo-Canadian scholar. He has delivered more than 40 invited talks at various institutions around the world. He has authored more than 210 research papers in various international journals and conferences. He has also co-authored 3 textbooks and co-edited 2 books and edited 8 edited volumes of research papers. His active collaborations include academics from Canada, Chile, China, Germany, India, Poland, Tunisia, UK, and USA. His areas of interest include artificial intelligence, information retrieval, data mining, web intelligence, and intelligent transportation systems. He has served as the general co-chair, program co-chair, review committee chair, program committee member, and a reviewer for various international conferences on artificial intelligence and data mining. He is also on editorial boards of a number of international journals. His research has been supported by Natural Science and Engineering Research Council of Canada for 25 years, as well as other funding agencies including NRC, IARAP, and MIX. His total research and development grants as of May 2020 exceed $2.5 million, with $2 million came from last 5 years. He has collaborated with more than 25 companies on projects ranging from feasibility studies to product development. He has supervised 135 research students, including 1 PDF, 9 PhD, 77 master degree, 48 undergraduates. He has coached highly successful academic teams for computer programming as well as software development competitions. He has also served on the National Science and Engineering Research Council of Canada Computer Science Peer Review Committee. He has been awarded an Alumni Association Excellence in Teaching Award, Students Union Faculty of Science Teaching Award, and President's Award for Excellence in Research at St. Mary's University, Canada. Such an eminent personality came over here to deliver talk to the participants of two-day international webinar on data science using Python. So on behalf of Department of Statistics, I welcome this eminent researcher and ask him to take over the proceeding. Thank you. Welcome, sir.
Thank you very much. I just want to make sure that you can actually see the screen where there is a slide.
Yes, sir. Yeah. Your screen is visible and you also audible.
Okay, great. Thank you very much. So I'm going to talk about clustering with some emphasis on rough and fuzzy clustering. Somebody else is sharing something. I don't know what's going on there, but I see somebody else presenting, Jagan Mohan.
Mr. Jagan Mohan, please stop sharing your screen. Thank you.
Okay, thank you. I see that there are a lot of participants, like 128. So there is a pretty good chance that some of you do not necessarily know what clustering is. Again, whoever is the host, can you block people from presenting other than me?
Mr. Jagan Mohan, please stop.
Or if you could just
yes, Professor.
If you just delete this participant.
Yes, Professor. We make an attempt.
Yeah.
Dr. Gandhiya Vendhan. Okay. Sir, Professor removed Jagan Mohan. Okay. Please, you go.
Okay, thank you. Yeah.
Sorry for the inconvenience.
Yeah, that's fine. I think you should take control. So, like only give certain people an ability to present and so on. Okay. So what I'm going to do is actually introduce what clustering is so that everybody is aware of what is going on. And then we will go from there. Right. So what I'm going to do is now escape out of this. I'm going to start a little whiteboard, if you will, and then just illustrate how clustering can be useful. So just imagine we are in a we are analyzing data for a retail store or a chain of retail stores, and then what we want to do is we want to find out what kind of customers we have based on their loyalty and their spending potential, right? Because you want people who can spend a lot, and you also want people who are loyal to our store. Because just because they have money, if they don't come to your store, then they are not very useful. So in this particular case, when it comes to loyalty, one way to look at loyalty would be by looking at how many times they visit your store, and then spending potential could be spending potential could be just how much money they are spending in the store. That is how much money. So the revenues that we get from that, right? So I could say visits as my x-axis, and then I could say revenues or spending as my y-axis. As my y-axis, right? So if I do something like this and then plot my customers in this then maybe I could get a whole bunch of people over here. Generally, life is not that good, but let's just say that we get some people here, then we get some people over here. So like one group over here, one group over here, then maybe there could be one group over here, right? And then maybe there could be a group over here. And unfortunately, a lot of your customers will probably fall somewhere here. Right. So let's say we have these 5 different corners in our data. Then we might be able to make some arrangements, like some decisions, marketing decisions based on what you see here. So let's just say that this is like, I fall in this particular category, right? Let's say somewhere here, say my sister, I'll just call her S, who falls in that category, and my daughter, let's say, falls in this particular category. And actually, it in fact is the case when I look at the spending habits of me, my sister, and my daughter. We tend to fall in completely different categories. And then what will happen is then you want to use this knowledge to exploit the spending and visiting habits. And I'll just explain to you why that is the case. So say for example, these people here that we see in the middle, they are solid people, right? They spend reasonably well. They come to the store reasonably well. So they are reasonably loyal. So, those are the, you want them. The ones over here, they're not very useful, right? They don't come often. They don't spend much. And as like a lot of times they would represent 60 to 70% of your client base anyway. So we can ignore those. These ones, you want to, they are good for you, right? Now, like you want to have, you want to give a lot of attention to them. Now, what about the group over here, right? I mean, I call that S. Say, as I said, my sister maybe belongs to that particular category. She does not go to go for shopping a lot, right? But then when she goes, she's like, bam, 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 buy a whole bunch of things, doesn't really have time to worry about how much anything costs, and leaves.
What is this meeting under?
If everybody could mute their microphones, that would be great. Okay, so the top left that I have designated as S are the people that you want to target them so that they do not waste their time when they come to the shop. So a lot of times, and it has intensified since this COVID. What we do is there are a whole bunch of parking spots that are reserved for people who just come in and pick up whatever they have ordered. So, for example, the people from this group could just order online or through phone, and then they could just come in. They have a parking spot reserved right at the front of the store. They walk in, their shopping bags are ready. They pick it up and then they leave. Right. So if somebody falls in that, you can make a decision like that. Now, what about me? Right. I mean, like the bottom right group that I have labeled as me. Am I useful? Because obviously I don't spend a lot, but then curiously I visit quite a bit. So in my case, if I'll give you an example. A long time ago, I was looking at smartwatches, and there was one that I really liked. That was Samsung Galaxy. Now I use the Apple one because it just works well with the iPhone. But at that time, and then I said, it was like I think it was like $4.99, right? Almost $500. And I said, it's too expensive. You know, I kept on looking at that. You cannot see my screen?
No, sir.
Yes, Professor.
Oh, yeah, you should have told me that. Yeah.
No. Dear participants, you go to people. There is two name called Pavan Lingaris. One is presenting. That you have to do it. That you pin it. Yes.
Okay.
Yes. Now it's okay.
Yeah. So thanks, and please speak up if something, because I could not always follow the chat. So if you cannot see the screen, then please speak up.
Yes, Professor.
Yeah. So I'll just quickly repeat then whatever I said. The group in the middle that I have marked as check mark, that's a solid customers that we have. The group on the bottom left is, I have crossed them because they don't spend much and they don't come very often. 60-70% of the people are in that group. We can ignore those. People at the top are the ones who just walk in, buy, and leave, and they don't come very often. But then they spend a lot of money. So what you like a store manager would provide them online shopping facilities, and then also parking space so that they can quickly just quickly come in and buy and pick up their shopping bags and go, right? So they can buy online and then pick up their shopping bags and go. Then I was just focusing on the one that's marked me, that's like me, that's Pawan. I was just telling you a story about a situation where I wanted to buy a smartwatch and I kept on visiting the online store pretty much. Like, you know, I used to at that time go 1 or 2 times a week or maybe even more. And then I look at this watch and say, it's good, but I didn't know if it was something that I wanted to buy. It was almost $500. And then one day, it was $300, a drop of $200, right? Then I bought it right away. Now, so in some sense, I'm also useful, because what happened after I bought it was the next week we had people like the same watch. Basically, there was an update, right? I mean, like, this was Samsung Galaxy, and then later on next week we got Samsung Galaxy 2. So what they wanted to do was bring in the new models. So they wanted to get rid of old models, and then people in the group that are marked as me would be the ones that they would be calling. Say, for example, so essentially when you want to clear inventory, these people will be useful. You know, like we, for example, look for winter wear sometime in February, because, you know, by that time winter is almost coming to an end, so nobody's buying winter wear anymore. So that's when they have clearance. So that's when we look for winter wear, right? So that getting ready for the next winter. So that would be another group. And then the group that I have marked up above, that is the top right, I have marked that as R, you know, for my daughter, Rucha. So she actually is quite as picky as we are. Like, you know, she would visit quite often, do a lot of study and so on. But then she spends more, right? So in this particular case, what you want to do is, like, for that particular group, you want to give them all the information they need, and then make sure that they don't leave. You know, like, I mean, again, there is an example for something like this. Our fridge broke in January, and my wife wasn't here, so I just, you know, made do with whatever I was eating out and so on. But then when my wife came, we bought the fridge, and then our daughter's fridge broke in May, and she did as much research as we did, but her fridge cost twice as much as ours, right? So as you can see, there are actually real people who correspond to these, and grouping them like this will help you do proper marketing, right? I mean, the group marked S, you want to help them shop quickly. A group marked me, you want to concentrate on them during clearance time. And group marked R, you want to give them a lot of information so that they can make informed decision and also spend a lot of money, right? So that's how we can use clustering for a good marketing case. I'm going to now what I'll do is actually let me just go back. And then get a new one. So typically, this is all good if you only have 2 dimensions, because we can view the cluster, eyeball it, and tell, there are 2 clusters, there are 3 clusters, there are 4 clusters, there are 5 clusters. But a lot of times you have multi-dimensions, right? I mean, even 3 dimensions you might be able to visualize, but 4, 5, 6 dimensions you will not be able to visualize. And going back to the clustering example, I could also add more criteria, right? Like one could be how much money you spend. Another criteria could be number of visits. Another criteria could be how profitable are you, right? I mean, if you buy items that are more profitable, then that is an indication. How many different products you buy could be another indication. And it can go on, right? I mean, so like as you can see, we are at up to 4 dimensions already, and 4 dimensions you cannot visualize. So somebody, Gauss Khan, if you could mute yourself and maybe turn your video off. You are on street, I suppose. So in this particular case, we don't know how to do this kind of clustering. And in any case, even if you had clusters, and let me just go back to my presentation here. Even if you had clusters that you can see, how are you going to write a program that will visualize these clusters for you? I mean, graphics is not the solution here. We already have the numbers. So long time ago, maybe in like 50 years ago, somebody came up with a very good solution, and that was called K-means. And I'm going to quickly illustrate how K-means works, so then you know that there is a solution that one can easily use. Okay, so let's say we have this is not my work. This was available on the web, so I downloaded it. It's very good. So I want to give credit to the person who has created. That's Padre Smith. So let's have a look at how K-means works. So here it looks like maybe we have 2 clusters. One could argue that maybe you have more, but 2 seems like a reasonable answer here. So what I'm going to do is I'm going to try and identify these, right, using the K-means algorithm. So K-means algorithm, instead of saying this object belongs to this cluster, that object belongs to that cluster, what it does is it finds out the centroid of these clusters. So we can say that so what we are going to do is just try and locate the centroid of these clusters. And the way it works is we randomly identify some clusters. The chances are that our guess is going to be wrong. So I'm just going to do that here. You can see that I threw a dot at the board, and then my dot landed in the wrong place. So I'm saying that my clusters centers are where my dots landed, but that's wrong answer. But we can still go ahead and identify the objects that belong to first cluster closest to the first centroid, and objects that belong to the second cluster closest to the second centroid. And that allows me to recalculate my centroid. And then you can see when I recalculate the centroid, it started separating. right? It's going in the right direction. Then I can again find out the objects that belong to the first cluster and the second cluster, right? Now, I still have some errors. I recalculate the centroid. It seems to be just about right. I will find out what objects belong to first cluster and the second cluster. And I think we got it, right? So I'll recalculate the centroid. It's moved slightly, but then from that point on, it does not change, right? The centroid stays where it is, then we will just leave it at that. So as you can see, this is a fairly simple algorithm. Actual clustering problem is NP hard because it involves optimization. There are certain metrics that you use to decide on the quality of a clustering scheme. And in order to optimize that, it will be NP hard, right? The actual time required will be almost n factorial. No, sorry, actually, k to the power n. Where k is the number of clusters that you want to group n objects into, so the actual time would be k to the power n, somewhere in that neighborhood. So that is clearly infeasible. This particular k-means algorithm approximates the clustering solution. In this example, it worked very well. It doesn't always work very well. So what you want to do is you want to, start, run it a few times because it depends on where your first guess was. So if you try multiple first guesses, eventually you will get a good answer. And as I said, there is cluster quality indices that we can use to decide which one is the best solution. Okay, so this is the simple algorithm. There is no new research in this particular case. It is, as I said, I think it came out in '67. That's when the paper was published, K-means. So that is more than 50 years ago, right? That it happened. A lot of things have happened since then. So I'm just going to go again to my whiteboard. And get a new whiteboard. And let's say we have I'm just staying with the two-dimensional example, but we have to remember that typically we are looking at 7, 8, 10 dimensions at a time when we are doing this. Let's just look at some examples here. So let's say we have these are objects. I just want them to be a little bit more visible. Actually, I might as well get a proper I am going to open a file here. Okay, so Mahmoud, can you turn it off? Can you mute yourself? Whoever is the organizer, you should be able to mute him. Can the organizer stay on top of this?
Hello. Hello, good evening, everyone. I am Mahmoud, Dr. Mahmoud Benarive, a student with University of Cameroon, West Africa. I'm very happy to be in the midst of an erudite people like you. My question is that, are you with me?
Yes, I think yeah. So can we have the questions later on? So we will have questions later on, okay? Because we haven't even started yet. When I describe a few things, then maybe at some point there will be questions. So as you can see here, we have a two-dimensional data set, and then if you look at this, you could say there are 3 clusters, or you could say there are 4 clusters, or you could say there are 5 clusters. Because the 3 clusters are obvious. The middle 4 ones are can form 1 cluster, and this is becoming a very problematic. This is breaking the flow. I hope now everybody can see my presentation or not. Not yet.
Yes, we are able to see.
Okay. So Yasholata, if you could mute yourself. Thanks. Okay, great. Thank you very much. So here we have a situation where you could have potentially 3 clusters, 4 clusters, or 5 clusters, right? So I'm going to just copy this into my okay. So here we can see that there is 1 cluster here for sure. This is another cluster, and this is another cluster. So we can say there are 3 clusters, but you can say these 5 could be a separate cluster. Actually, if you look at it, you could say there is 1 cluster here and there is 1 cluster here. So you could have potentially 5 clusters. So we can just say this is cluster number 1. This is cluster number 2, and this is cluster number 3. And then this could be cluster number 4, and this could be cluster number 5. Okay, so we can see there could be potentially 5 clusters, but then given the density of clusters number 1, 2, and 3, having something like just 1 in cluster number 5 does not make sense. Only 4 in cluster number 4 may or may not make sense, right? So this is where the soft clustering comes in. So what fuzzy clustering will do is it will say that I'll just now go back here and get rid of some of these annotations again, so I can put new annotations. So now just say that in this particular case, we could say this particular object over here belongs to this cluster, and also it belongs to this cluster, right? So that's what we mean by soft clustering. Crisp clustering means that you have to either force that particular object into one or the other cluster. In that particular case, you will put it in the bottom cluster. But really, it doesn't have to be. What we can say is that it belongs to this particular cluster with a fuzzy membership of, let's say, 0.6, and it belongs to this cluster over here with a fuzzy membership of, let's say, 0.4, right? So now what we have is this particular object over here. This particular object over here now belongs to 2 clusters, one with a fuzzy membership of 0.6 and the other with fuzzy membership of 0.4. So that is the essence of fuzzy clustering. Now we had some success in creating an alternative to fuzzy clustering, because sometimes when you have 10 clusters and if you try to give memberships of 0.3, 0.2, 0.1, it becomes confusing. So what we said was we can just use rough clustering, where we do not assign numbers, but we just say that this particular object belongs to both the clusters. So we don't have numbers, but we say it belongs to the two clusters, this one as well as that one. So it's on the boundary region of both those two. So what we have here is this is the core of the first one, this is the core of the second one, and then this one is in the boundary region. So that's what we mean in rough set theory as upper and lower bound. Actually, so we have this particular object. Let me just put it again. I'm just going to remove the annotations, and then here. So we can see that this particular object belongs to two clusters. Core of so if you only had this one object in the boundary region, then what we can say is that we have this is an upper bound of the bottom cluster, and this is the upper bound of the top cluster, and this is the lower bound of top cluster, and this is the lower bound of the bottom cluster. So the object in question that we are looking at over here belongs to both the clusters, maybe, right? But then objects that you see here, they most definitely belong to the top cluster. The objects over here, they most definitely belong to the bottom cluster. They do not belong to any other cluster. But the one in the middle that we see here, it may belong to the bottom cluster or the top cluster, right? So that is the basic. That is the soft and rough clustering in a nutshell, like fuzzy and rough clustering in a nutshell. Fuzzy clustering will, for that object in question in the middle, will assign a membership, say 0.6 to the bottom cluster and 0.4 to the top cluster. And in the rough cluster, instead of assigning numbers, we just say it may belong to either the bottom cluster or the top cluster. We just don't have enough information to commit one way or the other, right? So that is the difference between these two clustering, soft clustering mechanisms. And if we are going to go with crisp clustering, then that object has to be forced into one cluster or the other. Okay, so that is what we mean by soft fuzzy clustering and rough clustering. So I think I hope we have enough introduction. Okay. We have enough introduction and that we can now go ahead and look at some applications, because this is all very good. I wanted to focus more on the application side. As I said, as in the introduction, it was mentioned, I work with a lot of different companies, and we have used this for all kinds of applications. And I'm going to just show you three. A lot of others I cannot show because of privacy concerns and so on. Not so much privacy. I think it's intellectual property which belongs to them. Okay, so let me just go back here. I just want to acknowledge my co-author here, Matt Triff. He's a technical advisor for data science for Defense, Department of National Defense. He was my student, and incidentally, he's also married to my daughter. Okay, so we are going to use one example here. This is web data. Yelp.com, it's like Zomato and all of that that we see in India, where people are people review businesses and so on. So Yelp.com doesn't just do restaurants, all kinds of businesses. So in like 7 years ago, they released a large data set covering Phoenix metropolitan area. And what they had was we have reviewers and businesses. So based on the number of reviews from different categories, so we can have 1-star reviews, 2-star reviews, 3-star reviews, 4-star and 5-star reviews. So what we did was we have to come up with the representation, right? So what we said was that a reviewer will be represented by the total number of reviews they submit, because submitting a large number of reviews means they're active. But if they submit too many reviews, then maybe they're just professional reviewers. Maybe you don't want to put too much weight to their reviews. It depends, right? And then the votes, because you also get likes and dislikes for these reviews. So the votes would also indicate how good the reviewer they are. So as we can see here, a reviewer is represented by how many total reviews they had, how many 1-star, 2-star, 3-star, 4-star, and 5-star reviews they had, and how many votes they got. So there is a total of 7 dimensions that represent a reviewer. A business is also represented by total number of reviews, because if they get a lot of reviews, then that means they are popular. And then again, how many 1-star, 2-star, 3-star, 4-star, and 5-star reviews they have. Okay, so we are first going to use the crisp clustering, where that means an object is forced into one cluster or the other. You cannot have a maybe situation. Maybe this, maybe that is not allowed. And I'm just going to just show you the results. So we decided that there would be 7 clusters, and there's one wants to know how one decides how many clusters we should have, because K means as soon as once you fix the number of clusters to be K, then K means works very well, but you don't know what the K should be. So in this particular case, we decided K should be 7. Why did we do that? Maybe it will be a good idea to illustrate that particular situation. So I'm going to just get a new I actually have real life data, but I should not share it. Especially, I'm assuming this thing is going to be recorded. So what happens is, let's just say there is something called error of clustering, okay? And then I'll tell you how one can calculate this particular error. So there is error of clustering. Every time you combine 2 people into the same group, you are introducing some error. Going back to the example of marketing. If say it is like if you have a separate, if you study individual customer and do marketing individualized for each customer, that is the best situation. But you have like tens of millions of customers, right? So you cannot have tens of millions of marketing strategies. So you group people. So let me just say that Sundararajan and or maybe let's just go with my daughter and me, right? We are 2 different people, very different people. So if we are put into the same group, and then if you have a marketing strategy that is aimed for both me and my daughter, then you are making a mistake, right? I mean, you are introducing error in your marketing. Because I mean, like you should be sending her information about expensive products and sending me information about cheaper products, right? Remember, her fridge costs twice as much as mine. Just to give you an example, winter is coming, right? She bought a hat. Her hat, just a hat, winter hat, costs $400. Mine, we bought it on sale for $5, right? So like her hat cost 80 times as much as mine. By the way, I gave that hat to her as a present eventually anyway, so I paid for it. But nevertheless, she wears a $400 hat. I wear a $5 hat, right? I think mine is as warm as hers, but I try telling her that. But anyway, if we are in the same group and if we market for both of us using the same tactics, you're making an error, Okay, and I'll tell you how to calculate the error later on. So let's just say there is an error. So every time you group people, you are introducing error. When you combine two groups, you are introducing error. So what happens is this error goes up like that. Okay, as you decrease the number of groups, actually, sorry, this is the number of groups. Okay, that's not error. That's the groups, the number of groups. Okay, so that's your K, number of groups, and this is your error. And the error keeps on going up. And then at some point, it starts going up a lot. Okay, so this is where your best grouping is. Your K that you choose should be somewhere in the middle. You know what is called as elbow of the curve. Thanks, Anuradha and Department of Computer Engineering. Okay, so what? How do you calculate this error? I'll just give you a quick. So, if somebody could mute Prithvi. So, if you have two clusters. If you have two clustering schemes, can you please unmute Prithvi, please? Prithvi Saha. Thanks. So in this particular case, let's say all the objects were compact in one cluster, and here in this case, the objects were sort of scattered. Then this is the better one. I mean, I typically try to ask question, but in this particular, this is the better one because objects that are in the same group should be very similar to each other. Okay, so this is not good. Now, what I'm going to do is show you another situation. So here, I'm just going to delete this here. Okay. Now let's look at another situation where they are about the same size, but then just pretend they're same size. Okay, my drawing is not very good. I was meant to be my first degree was in civil engineering. Can you imagine what would have happened to I wouldn't have been able to make a living with my kind of drawing. Thanks God for computer science. But anyway, so here we can assume that they are both of the same size, the clusters, but this is farther apart than this one. Okay, so you can see the distance. So what we want is objects in the different cluster. So in this particular, this is the wrong one. This is a better one. Objects that are in the different cluster should be as far apart from each other as possible. So as I said, like my daughter and me, very different people. So it makes sense to have them because we are very far apart from each other. So we should be in different clusters, right? Remember the $400 hat? Oh, by the way, she also bought another one for her husband, and then she has asked me to pay for that. His birthday is next week, so I will be paying for that as well. So as you can see, it bothers me that I'm spending $800 for two hats. Anyway, so the objects in the different clusters should be as far away from each other as possible. So typically, this is a little harder to test. There is an index called Davis-Bouldin index that we can use. But the error that I showed you before, that is essentially based on the spread of the clusters, right? So let me just delete this. So it is basically based on the spread of the two clusters. So here, if they are equally close to each other, and if you have something like this as opposed to this, then this is the so in that particular case, This is the beta one. The top one is the beta one, and the bottom is the wrong one, right? So that's how you calculate the error, by looking at the spread of these clusters, and that's not that hard to do. We can just use simple Euclidean distance and add the distances to get that. It's called within SS. If you have done any if you're using R, then there is something called within SS. In Python, there is another measure. I don't think we will have time for me to show you the code, but in Python, we use a different measure to calculate this as well. I'll just go out on a limb and I'll actually show you one such. I don't think you will be able, I'm not giving up too much information by showing you the errors. So here we were actually, this is for a healthcare facility, and we were looking at the residents, and then you can see that the sum of squares is the elbow of the curve that you see. You can actually see that happening in a real life situation, where we decided that the right number of clusters in this particular case would be 5. So the point is that it is possible to find out what is the right number of clusters. So here we said 7 is the right number of clusters. So now let's just have a look at these clusters in a little bit more detail. We can see right here we have this is from the CRISP clustering, and then we have like this. The cluster number 7 has 104 elements. So the size is on the right hand side. It has 104 elements. And we can see that they most of their reviews are 4 and 5 star, right? So 38.59 and 38.13 are 4 and 5 star. On the other hand, if you look at the total number of reviews that they submitted, total number, this is for the business, right? So most of their reviews are 4 and 5 star. And they also have a lot of reviews. So on an average, they get 335 reviews. On the other hand, if you look at cluster number 1, SBC1, then you can see that the size is 2073. On an average, they got only 6 reviews, and most of them were 5 star. So that's a good indication. What is the difference between cluster number 1 and 2? You can see that they have the same number of reviews, 5 to 6. But then for cluster number 2, most of the reviews are 1 star, as opposed to for cluster number 1, most of the reviews are 5 star, right? So you can, if you do this kind of grouping, you can actually create profiles. I'm just going to, and then you can describe them using simple English, right? So here, cluster number 1, fewest number of reviews, mostly 5 star. Cluster number 2, fewest number of reviews, but most of them are 1 and 2 stars. Cluster number 7, largest number of reviews, mostly 4 and 5 star, right? So we can actually describe these clusters in English so that the marketing managers could understand what these things mean. Like the numbers are good for us, but not necessarily good for people who want some kind of description of these. Okay. I'm going to fast forward this. You can also do the same thing with reviewers. One thing that I want to show you here is for the CRISP clustering. You see cluster number 6. There we found out that cluster number there would be 6 clusters. Actually, there are 7 clusters. There's just an error here. But then you see the cluster at the bottom. It has only 2 reviews. Two people belong to that particular cluster, and then they have total of 442 reviews. So are they any good? But then if you look at their votes, they have 13,000 votes, right? So so you can see that maybe these are professional reviewers, but you can trust them. Same thing for, let me just pick another reviewer here. Another group, cluster number 5, we see that it has 16,569 members and has only 3 votes, and they only gave 2.5 reviews on an average. We can also, if you look at the top 3, they seem very similar, but then the difference, in terms of the number of reviews that they have and the number of votes that they have, but the difference is that the top one has gives most of them as 1-star reviews. The second one gives most of them as 5-star reviews, and the third one, most of them are 2-star reviews, right? So you can actually identify how hard these reviews are by looking at how they have been rating the businesses. Now, what I want to show is a difference between this. I'm just going to flip to this side quickly. The point is that you can describe whatever we saw here in plain English. But then if you do the same thing with fuzzy clustering, what happens is, and I'm just going to compare, just go directly to the fuzzy clustering of reviews. Okay, because this is where you can see a stark contrast between the two. So look at this one here. The profiles are similar, but they are a little bit more moderate. But if you look at the size, you can see it's equally distributed. The smallest one is 4,079. The largest one is 13,842. So the distribution is fairly uniform, as opposed to when I use crisp clustering of the reviewers. Crisp clustering of the reviewers, you can see here that we had one group that only had 2, right? So what happens when you use fuzzy clustering is, because you're not forced to put an object into one cluster or the other, an object can belong to multiple clusters. The clusters tend to be more moderate, the descriptions, and when we are using crisp clustering, the clusters tend to be more extreme. Now, it's not necessarily a good thing or the bad thing, right? Because what we can do is, in this particular case, we can use crisp clustering to eliminate outliers. Outliers do not necessarily mean error. They're just exceptional cases. So these 2 that we had, or even the 75, we can separate those. So we can take the 77 of these reviewers out, or maybe just the 2 as outliers, and then recluster. So crisp clustering in this particular case is good for identifying outliers, and fuzzy clustering later. So what I would do if I were a practitioner, I would first use crisp clustering to identify the right number of clusters. Then I would also use crisp clustering to remove the outliers. There would be exceptional situations, and then I would do fuzzy clustering to get a better profile, right? So that would be that is generally my prescription for using clustering. Use crisp clustering first to identify a number of clusters. Use crisp clustering to get rid of outliers, or remove or separate the outliers because they might be useful, and then use fuzzy clustering to create moderate to create proper profiles. Okay, so that's all I'm going to say about using web data for clustering. That's what we did here. We compared crisp clustering with fuzzy clustering and how both of them could be used. Now, what I want to do actually is, because the time is limited, if Dr. Vendhan could tell me, oh, sorry, Velan, sometimes what happens is I'm looking away from the thing and then, so how much time do I have?
No problem, sir. You convince them.
Yeah, I'm sure like at some point they will lose interest. So what I will do is I will actually keep it for another 15 minutes.
Yes,
Okay?
Professor, you can go ahead.
Yeah, sure. Yeah, we don't want to overdo it either, right? So the goal would be I'm going to show you different applications where you could use that, and then also show you a comparison of rough clustering and crisp clustering, because we already saw a comparison of crisp clustering and fuzzy clustering. So let me just flip through. I have like, I mean, there is, I could talk for this for 2 days, right, at a time, and also illustrate all of this using actual R and Python code. But let's not overdo that right now. So I'm going to give you another example. So we saw web-based example over there. Now I'm showing you an example here of transportation. So my first degree when I came to Canada was in traffic engineering, where I was modeling traffic. And that's how I got interested in computer science and switched to computer science. So I was doing data science before data science was a word, right? Here, what we have in Canada, what happens is, let me just go back. Okay, so in Canada, there are a lot of counters. Now, this is an outdated technology, with all these cameras and things like that. But like, some of this data comes from 1980s. It was very expensive. They used to dig through highways and put induction loops. So they could count the number of vehicles that are passing through highways. So this is from Alberta, oil-rich province of Canada, we had maybe 200 different points where we got data as to how much traffic was there. So what happened was, what happens in Canada is, as you know, it's cold, right? I mean, in winter, and people think Canada is cold, but not in summer, right? So I just want to give you a little bit information about Canada. We are on the Atlantic coast in Halifax. The temperatures, our December, January, February are no fun. March and November, it's okay. April and October is not bad. So I start jogging in April, and I jog in April and May, and then I stop jogging in middle of June, and then I start swimming in the lake. Then I swim, and I thought my last day was 10 days ago, but today again the weather is nice, so I'm going to go for swimming. So this would be like my 55th day of swimming. So it's not as cold as you think, and this is like lake swimming, right? I mean, this is the lake that freezes in winter. And then now I have already started jogging a little bit, and then I will jog in rest of September and October. So the point is that the weather has a lot of impact on our lifestyle. And that can be seen in the traffic patterns as well. So the traffic picks up in summer, and then it goes down in winter. And we can use that to decide what type of traffic goes on a particular highway. Typically, people travel for 3 different reasons, right? A long distance, they want to go from one city to another for business or whatever. Commuter, they're going to work, and not during COVID, of course. and then recreational. They want to go to parks and all kinds of activities, right? So we want to, we want to decide what is the predominant usage for a particular road by looking at the traffic pattern. When I was like in 80s, when I was doing this, we used to use crisp clustering, and then we could not, we could not in good conscience use 3 clusters. There were 5 to 6, sometimes 5, sometimes 7, up to 7 clusters. And then we would say, oh, this particular one is definitely long distance, this one is recreational, this one is commuter, and then we would assign saying, oh, this is a little bit of long distance, little bit of commuter, right? Because we did not have the rough set technology at that time, rough clustering, until I came up with it in 1998. So we used to artificially create 7 clusters. But then when I use rough clustering, I can actually create 3 clusters. And then when I look at the map, they make sense. Let's just look at long distance one. That's the diamond. No, actually, let's start with the commuter. That's the triangle one, right? So that's the one that you will see is at the bottom when you look at the peak, because the commuter traffic does not change that much. You have to work. Some people, you have some holidays in summer, but generally you have to work, right? So the commuter traffic is more or less flat throughout the year. Long distance traffic slows down in winter a little bit and goes up a little bit in summer, but not by a whole lot. So that's somewhere in the middle. And then recreational traffic makes a lot of difference. You can see it spikes in summer and bottoms in winter. And when I used rough sets, all I needed was 3 clusters, and I could see this very clearly. As opposed to crisp clustering, sometimes we had to go as many as 7 clusters to do that, right? Because then we would say a little bit of this, little bit of that. So we were doing rough clustering without having proper mathematical model. With rough clustering, we could do that without, creating artificial clusters. One thing to note here, I just want to show you for the, if you look at that hollow square and November and December, it bottoms in November, but it picks up in December. And that's because of the Christmas time, right? Alberta, when you come to Canada, you should visit Alberta. There is something called Banff National Park and Jasper National Park, one of the most beautiful places that you will ever see. It's as good as Himalayas, as good as Alps, and in some cases, in some ways, better. There is a lot of skiing that goes on. So you can see in November, there is no skiing. December, there's ski, so you go up a little bit. But then you will say, oh yeah, but then what about a little bit of this and a little bit of that? That is also captured using the rough set technology. So here we can see that we have a counter called C009141T, and 91 means in 1991. So here you can see that's the one that's shown by triangle, and that was a little bit of long distance and a little bit of recreational. And if you look at the map, it was between Calgary, which is a major city in Canada and Alberta, and Banff National Park. So it was right in the middle. So that is also part of Trans-Canada. So it catches the ski traffic and actually also summer traffic for visiting the national park. And it also catches the long distance traffic on the Trans-Canada Highway, right? So we managed to see that this C009141T belonged to both the clusters, which was allowed in the rough set formulation. There is another example here that I'll show you. This is on the other side of the Calgary. It is like a suburb, like a bedroom community, as some people will call it. So in this particular case, you can see C013201T was on the other side of the Calgary, still on Trans-Canada Highway, and people used to, some people like 3-4 acre lots for their houses, so they would buy houses there. on a large, and then have horses and whatever, right? But then they would commute to Calgary. So this showed a pattern that was neither long distance nor commuter. So our rough clustering put it in both the clusters. So the rough clustering captured the essence of clusters very well. Now, I will not be able to go into meta clustering and so on. But what I want to show you is another example where you can use clustering. So here, what we did. So let's just focus on the first part of this. Okay, so here what we did was we used we grouped customers based on their revenues, visits, profits, and products, and then we can see that we have cluster number 1. That's our best cluster. The values were normalized for different reasons, but you can see the cluster number 1 was my best cluster because there was a lot of revenue, a lot of visits. The profit was quite high as well, and the number of products that were bought were quite high as well. So what happens is, like, when you're looking at customers, then you want to look at, like, revenue tells us their spending potential, visits tells us their Tusharajan? Revenue tells us their spending potential, visit tells us their loyalty, profits tells us their profitability, and products tells us also loyalty. You know, if you buy a lot of products from our store, the chances are you're not going somewhere else. But if you only buy 2 or 3 products, there's pretty good chance that you might be going to the other stores, right? So between products and visits, we get their loyalty. But then you can do the same thing for products. In the products, you can look at popularity by looking at how many customers buy this, how many visits this particular product is bought in. That's an indication of loyalty. How much quantity you sell, how much revenue you sell, how much profit you make. All of these can be used for also grouping your products, you know, based on how popular they are, how much profits they produce, and how much revenues they bring. So I just wanted to again show you an example. We don't have time to go through all of these, but you can see that the real life example of where we can group both customers and products. And last but not the least, I just want to show you how you could also do this for social networks. And I'm going to use a phone as a social network. What we did was, like, we got some data, like somebody from MIT collected a lot of data for 102 people. They gave them a free phone and collected their data. So then we decided we wanted to find out how to group these. So we started, and then we had to modify our representation later on, but we started with the hypothesis saying average duration of phone calls. That tells us about people, right? So I'm just going to, my wife is actually downstairs. She is not going to hear this, so don't tell her. But like, you know, when she calls home, you know, she could talk for an hour or 2 at a time, right? When I call my mother, 5 minutes, how are you? At some point, I start irritating her. She starts irritating me. I put the phone down, right? You know, we have this phone plan. She has her own plan. I have my own plan. So I renew my, like, you know, $10 lasts me 4 months. $10 lasts her 2 to 3 weeks, right? So so you can see that, you know, like, so we are different people, very different people. and our average duration of phone calls also tells that. Average number of weekend versus weekday calls. My calls tend to be on the weekdays. Like, I call a lot of people, so business related calls. My wife's phone calls tend to be on weekends when she's not working from work. She doesn't call. So again, you can tell the difference by looking at the number of weekend versus weekday calls. Me and my wife, different people. Average number of daytime versus nighttime calls. My business calls during daytime, her business calls at nighttime. Sorry, her calls nighttime typically tend to be personal. Outgoing versus incoming. I'm not going to talk about me and my wife here, but that also can tell us about the person, right? If you make a lot of calls, then you are the one who is calling. But then if somebody is calling you, then I'm sorry, I'm just looking at Rachakonda there. He's on bicycle, I think, and he's going through the street. So interesting. Anyway, so that will also tell you what kind of person you are. If you have a lot of incoming calls and not enough outgoing calls, that means you're a popular person, you're an important person. Then average number of SMS, right? I mean, like the text messages. If you send a lot of text messages, then you are a certain type of person. You don't like to talk to people. You just want to send them messages. And then, like the average number of voice calls. And then we also figured out that average number of long duration calls also is a good indication. So it's sort of like one, but little different. So we figured that so we had to do a lot of experimentation to characterize a phone call a phone caller. And as you can see, every one of these attributes that we came up with was important, and it told us something about the person, right? So as you may have heard this, whenever you are doing data science, you are going to spend 85% of the time with like massaging the data. And one of the biggest things that you have to do is decide how to model a person. Like, you have a real life person who is making phone calls, and then you have to characterize that. And, you can use these particular attributes to decide what type of person it is. Same thing for products, right? You want to know how popular it is, how profitable it is, how much revenues it brings in. Same thing for customers. So it takes a lot of time to come up with that model. And once you have come up with the model, the actual thing that you're going to do, data machine learning, probably takes 10-15% of your time. So typically it's 80% for data preparation, 10% for machine learning, and 5% for analyzing the results. And analyzing the results is sort of goes back into data preparation again and again anyway. So what I wanted to do was talk about all of this, right? I mean, in the clustering, first of all, you have to model data properly. Then there's crisp clustering, there's fuzzy clustering, there's rough clustering. I would start with crisp clustering, use that to decide how many clusters you want, use that to identify your outliers, and then later on you want to you want to use fuzzy clustering to get better profiles, or rough clustering to get better profiles. Fuzzy clustering gives moderate profiles. Rough clustering gives very precise core profiles. So that would be my message. As I said, typically something like I have enough material for a workshop that can be half a day, 1 day, 2 day, depending on the time I have. I adjust my presentation. So thank you very much for the invitation. Yes, please feel free to share my video. I assume that's recorded and it is on YouTube. Thank you very much. I can take 1 or 2 quick questions, but probably not necessarily. Yeah, so my mail ID is, it's there for, I'll just type it here in the chat. Well, Dr. Vendhan has my phone number for WhatsApp. I do not answer WhatsApp messages. So, Pawan@cs.com.
Thank you, Professor.
Yes, yeah, and I will be happy to share the data sets. Yeah.
Yes, right, sir. Now it's
some of the
time
data, yeah.
for the participants to ask any questions to the resource person. So now it's open to audience. Please feel free to ask one or two questions due to lack of time. So now open to audience to pose a question.
Sir, good evening, sir.
Hi.
Good evening, sir. It's nice
Yeah, good evening.
presentation.
Yeah.
Sir, I want to clarify. Based on the data only, we are able to apply the clustering, or you really very nice presentation regarding the various types of clustering using fuzzy also. And how we can make it as based on the data only, we have to apply the clustering, or
Oh,
what is
yes,
that?
yeah. So it is actually first of all, when you talk to, as I said, like, I mean, the number of companies I have worked with is increasing every year. This year, right now, I have like active 8 projects. Actually total 10 projects with companies. And the companies have a problem statement, and then you have to twist that problem statement into a machine learning activity. Right. So when you get the data set, the first thing you do is business intelligence, like the data summarization, and then give that information to the client. Then the client is, and then start formulating their questions into machine learning activities. So after data summarization and visualization, the next step is clustering, where you can create profiles. When we got the retail data set, like the person said, all I want to know is size of a person's wallet, right? So that means how much money they have. And then once they know how much money they have, like how much disposable income they have, then they can figure out. So like 15% of that goes for grocery. Then you look at how much they spend in your store, and then decide whether you are getting a good share of their money, right? So now that is their problem. They don't care about clustering or whatever, right? So then you have to turn that into a problem statement. So my general methodology is data summarization, visualization, then profiling using clustering, and then you go to the supervised machine learning depending on the problem. And once you have done that, then the next step would be optimization, right? So for a business, that would be the standard steps that one takes. And I have worked with some companies for 3-4 years, and we have gone through these steps.
Okay, thank you, sir. I think clustering is one in the comes in the 4th stage or 5th stage. Therefore, if you're having a raw data, we have to process so many steps and only apply the clustering at the last. Am I right, sir?
Sorry. So as I said, there are 4 or 5 tasks, right?
Okay.
So the first one will be data summarization, visualization. That's where you'll do a lot of cleaning.
Okay.
Then once you have done that, which will take, like, I was teaching an executive MBA course, there was a person from Irving shipyard, like they have a $6 billion, it's a very big company. It's a conglomerate, sort of like Ambani Group, right? But very small compared to Ambani, of course. They have a shipbuilding contract with Government of Canada, the Navy. So he said that they spent 5 years cleaning the data, right? But once they have cleaned the data, they really want to make a use of that, because that was like a lot of work. So you're right. It comes after 5 years of work. But then you could do the clustering, the next you spend a year doing summarization and visualization. Then you do clustering, maybe another 6 to 8 months. Then you can do supervised clustering another year. And then you can do optimization and then use those results. So you're looking at a 10-year thing, and first 5 years would be just data cleaning. And big company, small company, same thing, right? Big company, bigger problems. Small company, smaller problems, but smaller resources.
So,
okay,
hello.
thank you, sir. Thank you very much for your clarification.
So, am I audible? I wanted to ask a
Yes,
question.
Narinder, yes, please go ahead.
So first of all, I must congratulate you for a very nice session. So we enjoyed it thoroughly. So I have a very small query. So I hope you are able to listen, right? Okay.
Yes, yeah, I can. Yes.
Right. So the query is in the sense that there are several methods of forming clusters, right? So
Yes.
I hope you agree with me that it's like, single linkage, complete linkage, average linkage, and so many others, right? So of course, k-mean clustering is also there, right? So all other which I've named, except this k-mean clustering, give you a random number of you never know beforehand that how many clusters will be formed, right? But even then, most of the time we do prefer k-mean clustering, right? So where number of clusters are fixed. So how do we really decide that which type of formation we have to take? So it should depend on which type of cluster.
The data that I normally deal with, the k-means class of clustering is the best one, right? But if you just have numeric data, like if you're representing some like an real life entity such as a phone caller or a what do you call a product in a superstore or a customer in a superstore or occupant of a nursing home or whatever, right? So they are represented. If they are representing numbers, then there is no so we are not using graph theoretic clustering here. So the best way to go would be the k-means type of clustering. So in k-means, as you said, you don't know how many clusters you have. So as I showed you, I would the first thing I would do is I would plot the errors, that is the within SS, and then find out the elbow of the curve, and then the elbow of the curve will give me hints as to what my k should be. And then you also have to be in touch with your client, because clients don't want too many clusters, right? Now there are situations where, like in my case, I needed 1,000 clusters, right? And I actually have the example in this presentation as well. I just didn't have time to get to that. Where we are not actually profiling, we are using the clustering for different reasons. But the elbow of the curve will tell you what would be the right number of clustering. And then you go from there in consultation with the client. And as I said, crisp clustering helps decide number of k-means would help you decide the number of clusters. It will also help you identify outliers. Then, if you wanted moderate profiles, you go with fuzzy clustering. If you wanted very very well separated cluster profiles, then I would suggest that you go with the rough clustering. So there are a lot of decisions that one has to make in a data science project.
Agreed, that is there. But once you've made the clusters, right? So as you said, k-mean clustering, though, I will say that k-mean clustering, you have already decided that k clusters has to be there. They may be 3, 4, or 7, whatever, right? Wherever other methods give you, as many number of clusters depending on the data set, because methods themselves give it. Anyhow, so once with that k-mean clustering,
let me just add something to that. I would not use those methods on a regular basis. Because what happens is those are very expensive. So like EM is the expectation maximization principle, right? So there's EM clustering, and EM clustering, as you said, would give you the number of clusters and the clustering again. But if you keep on using it again and again, then it always tries to find the best number of clusters. That's very expensive. So I would use something like EM at the beginning. Once I know the clusters for real time and doing multiple clustering, I wouldn't use that, because any clustering scheme that decides the number of clusters is very expensive, because it has to.
Anyway, I've got your point. My last query is, once clusters are made, say with k-mean clustering, so do you really then make some testing also that the cluster you have formed are actually suitable? I mean, certain statistical tests are performed to look at the suitability of the clusters.
Yes, so it depends on what your goals are, right? I mean, so if it is profiling, then the evaluation is subjective. You have to work with the client. If you wanted to have crisp, if you wanted, there are also quality of clustering measures, so within SS, or Davis-Baldwin index would tell you quality of clustering, or sometimes you're using clustering for supervised learning. Then the standard supervised learning matrix will also tell you the quality of clustering, right? So it depends on the problem. You use different ways to evaluate.
All right, thank you so much, Professor Pam.
Yeah, you're welcome.
Hello, any other question from the participants? Okay, if there is no questions, then I thank the speaker, Professor Pavan Lingaris. Yes, yeah.
Hello, sir. I just have one question. I'm also working with the clustering techniques. So, can you tell me the techniques which are suitable for large data? I mean, big data cluster. For big data, which kind of clustering can be suitable, and especially for geospatial kind of data?
Typically k-means is very fast, but if you it depends on what you mean. So if you're talking about stream clustering, then there are different, there are one pass clustering algorithms. But again, my preference is that you take a sample of the stream clustering and then do regular clustering. So do the clustering before using standard clustering mechanism, and then Narinder, if you could mute yourself.
I'm sorry.
Narendra, sir, please.
Okay. So as I said, like when you say large data, it's really not that large. Like if you cannot apply standard k-means clustering, then I would suggest that you look for the one pass clustering. But then the results start getting bad, right? As when you do that.
Add on to this one more question. What can be the terms of in terms of scalability? Which one is better?
So there is not a single answer, right? I mean, like what I would do is I would use sample or sections of the data. If it is like the real problem is when you have IoT data, okay? Because IoT data is truly large data set. So what we do is, like, first of all, you come up with the right sampling rate. Then also take the sections of the data set, and depending on the goals, I would still use the regular clustering just to get a feel of what my patterns look like, and then I would switch to stream clustering by using hints from there. Right? There are a lot of, like, if you just look for clustering data streams, you will find all kinds of one-pass clustering algorithms, but they are not quite as accurate.
There is one clustering algorithm called Clarence, clustering for large application with noise searching. So, do we have the variation which can incorporate some type of scalability to cope up with large amount of data, because it is already being on sampled data?
Can you spell that for me? Yeah, can you spell that?
Clarence.
The spelling.
CLRANS. CLARANS.
Yeah, I know that. Yes, yeah, I remember. I remember looking at that, and there are different.
So it belongs to the partition-based clustering family only.
Yes. So yeah, I don't like. I'll have to look at what the this shows right here, k square plus k n minus k is how much it costs, and I think this is based on sample, right? S is sample, isn't it?
Yes.
Yeah.
No, it's actually for noise search.
Yeah. So if you look at k means it depends on the so it is a linear one, like number of iterations multiplied by number of clusters multiplied by number of objects would be the time requirement for k means. And I'm looking at Clarence, which is big of n square, and Clara, which is based on I think sampling. I'll have to see what S exactly means there. But Clarence is expensive, okay, because K typically would be anywhere from 2 to 10 in most situations. N is literally in billions. So if you use Clarence, it's not even possible to do it for anything larger than 300. I have used partition clustering, and when the size goes beyond 300, you cannot use it. So Clara is its looks like its variation, which the implementation is complicated as it suggests, but it's based on S, which I'm thinking is I just have to see what S is in there, but I'm thinking it's either based on sampling or doing some partitions and working within those partitions. You are going to get less and less, lower and lower quality as you try to go that way. I don't see Clarence as a solution. It's big of n square.
Sure. If time permits, we'll discuss it sometime.
Sure.
No issues with all. Thank you, sir.
Thanks.
Okay, thank you, Nega. I think its time is up. So it's a wonderful section. So on behalf of the Department of Statistics, Bharathiar University, I wholeheartedly thank Professor Pavan Lingares for the wonderful section on classification techniques. So I thank once again Professor Pavan Lingares, and I request all the participants to join day 2 of International Webinar on Data Science using Python. And the feedback link is already put it in the chat box. Those who are not filled up, please kindly fill it up and put it your response written to our organizing desk. Now over to Dr. S. Gandhiya Vendhan.
Thank you, Professor. I am happy to end of the session. I am very, very happy to session for the eminent professor that given the good lecture and excellent lectures given the Professor Dr. Pavan Lingares, Professor and the Director, Department of Mathematics and Computing Science, Saint Mary University, Canada. So, sir, Professor, I sent the request early. Professor immediately accepted my invitation. Thank you, Professor.
It's my pleasure.
Yes, Professor, and also we have IIT alumni, so that I'm happy to again see the in the sessions. And also the chairpersons, Dr. K.M. Satyavil sir, Associate Professor, Department of Statistics, Bharathiar University, Statistics. And also Professor K.M. Satyavil sir is lot of support with the support with my one of organization. I am not telling that invitation, but is some of one of our organization of Satyavil sir. And thank you, sir. Thank you, Professor Lingares, Dr. Pavan Lingares, sir. Thank you very much, sir. And also participants and the deep learners.
Thanks,
we will meet the next day. Thank you, Professor. Professor,
thank you, and thanks for staying up late. Thanks.
Anything telling that something is telling? If you want, telling that.
Okay, so I'm going to I'll leave the session now with you.
Yes, sir.
Thank you.
Yes, sir. Thank you, sir.
Thank you very much.
Thanks. Bye.
Bye.
Once again, thanks to key speakers and K.M. Satyavil sir and all deep learner academicians, professors, faculty, students. Thank you. We will meet next day. Thank you. இல்லை வெயிட் பண்ணுங்க, கொஸ்டின் க்ளோஸ் பண்ணிடுங்க. ஏன்னா ஃபீட்பேக்கை வாங்கணுங்க. இவனுக்கு நம்ம டைம் கொடுத்து போயிட்டுங்களா?